The moon, our celestial neighbor, has always captivated humanity. Its silvery glow has inspired countless myths, legends, and scientific inquiries. For millennia, we've gazed upon its cratered surface, wondering about its secrets. What mysteries lie beneath its rugged exterior? One question has always lingered. Is there water on the moon? This question has puzzled scientists and dreamers alike for generations. The answer, surprisingly, might be yes. Recent advancements in lunar exploration have provided compelling evidence. And not just a little, we could be talking about billions of tons of water ice hidden beneath the lunar surface. This discovery could revolutionize our understanding of the moon. For centuries, the moon was considered a dry, desolate world. Its barren landscape seemed devoid of any life-sustaining resources. Its lack of atmosphere and scorching daytime temperatures seemed to negate any possibility of liquid water, let alone ice. The harsh environment made it seem impossible. Recent discoveries, however, have challenged this long-held assumption. Advanced satellite imagery and lunar missions have revealed the presence of water ice in shadowed craters and beneath the surface. This revelation opens up new possibilities for future lunar exploration and even the potential for human settlement. The moon, once thought to be a dry desert, might just be a hidden oasis waiting to be explored. Early telescopic observations of the moon revealed a landscape scarred by impacts, with craters pockmarking its surface. These early images painted a picture of a barren, lifeless world, devoid of any visible water. The moon appeared to be a dry, desolate place with no signs of the life-sustaining liquid we find so abundantly on Earth. Missions like the Apollo program, while landing humans on the lunar surface, seemed to confirm this dry reality. Astronauts walked on the moon, collected samples and conducted experiments. The samples brought back were primarily composed of rock and dust, further cementing the belief of a waterless moon. Scientists examined these samples meticulously, finding no evidence of water. This view started to shift at the turn of the 21st century. With the advent of new technologies and more sophisticated instruments, new technologies, both on Earth and in space, allowed us to probe the moon with greater precision. Satellites and probes equipped with advanced sensors began to reveal new data. What we found was a game changer, hints of water, not as flowing rivers or vast oceans, but as minute quantities of water molecules embedded in the lunar soil, but locked away as ice in the most unexpected of places. These discoveries were particularly concentrated in the permanently shadowed craters at the moon's poles, where sunlight never reaches, allowing ice to persist. This revelation has profound implications for future lunar exploration and the possibility of sustaining human presence on the moon. The presence of water could support life, provide drinking water, and even be used to produce fuel for further space exploration. In 1998, NASA's Lunar Prospector mission sent shockwaves through the scientific community. Its instruments detected an unusual abundance of hydrogen at the moon's poles, particularly within permanently shadowed craters. This hydrogen, scientists hypothesized, could be a strong indicator of water ice. Further confirmation came from India's Chandrayaan-1 mission in 2008, which detected the absorption of infrared light on the lunar surface, a signature consistent with the presence of water molecules. These groundbreaking discoveries opened up a new chapter in our understanding of the moon. The moon's polar regions, with their permanently shadowed craters, have emerged as the most likely reservoirs for water ice. These regions, especially the South Pole, are of particular interest to scientists and researchers. These craters, untouched by sunlight for billions of years, act as giant cold traps, preserving the ice in its frozen state. The temperatures in these shadowed areas can plummet to as low as -250 degrees Fahrenheit, making them some of the coldest places in our solar system. The extreme cold and lack of sunlight create the perfect conditions for water ice to remain stable over geological timescales. This stability is crucial for the potential future use of lunar water in human space exploration and even colonization. While the poles offer the most promising locations, there's evidence that water might exist elsewhere on the moon. Recent missions have detected signs of water in sunlit regions, suggesting that water may be more widespread than previously thought. Tiny amounts of water molecules have been detected in the lunar soil, suggesting a thin layer of water molecules bound to the lunar regolith. This discovery indicates that the moon's surface is more dynamic and complex than we once believed. These discoveries, while significant, raise more questions about the origin and distribution of water on the moon. Scientists are now investigating whether this water originated from ancient volcanic activity, comet impacts, or solar wind interactions. Understanding the source of lunar water could provide insights into the moon's history and its potential for supporting future missions.